We've all witnessed the beauty of a shooting star, but what would happen if an asteroid was on a collision course for Earth? Could we detect it ahead of time? And more importantly, could we stop it?
I believe I have an answer. Now you see, asteroid impacts are serious business. When I was in second grade, Mrs. McGonagall told us that the dinosaurs, the ancient dinosaurs, died out because they had small brains, maybe like my old boss. But even she knew that was kind of lame, that theory was nothing. It turns out, in my lifetime, people found this crater off Chicxulub, Mexico. This crater was so big. How big was it? It was so big that an asteroid hit the Earth, or impactors hit the Earth, threw so much stuff into the Earth's sky, it was bigger in diameter than the Earth itself. So the Earth was surrounded by red-hot rock for weeks at a time, cooked everything. And just the animals that lived in burrows and caves, our ancestors, led to us. So, serious business. You may recall, Valentine's Day 2013, Chelyabinsk, Russia. Airburst. See, if you're an asteroid and you're going 10 kilometers a second, 20 kilometers a second, and you hit the Earth's the atmosphere is like concrete. It can't get out of the way. So the asteroid just explodes, an airburst. So these asteroids are serious. Most of them are very small. If you're under 10 meters in diameter, you hit the Earth's atmosphere, you burn up. Big blue streak, blue, green streak, white streak, and then humans make wishes upon you. I don't know how efficacious those wishes are, but people do that. All right, so if the asteroid starts to get bigger, starts to get into the 25 meters, into 45 meters in diameter, then you get Meteor Crater, Arizona. Wham! Huge thing. That would be like a city killer or a county killer. And then when they get to be 100 meters, 140 meters, now you're into a country killer. And then they get bigger than that, it's a continent killer. Much bigger than that, and you're taking out whole races of ancient species. So, what if we found an asteroid that was headed our way? How would we find it? How would we find an asteroid headed our way? That's a good question. Well, you can use telescopes. Skilled people can point the cameras at the sky and look for fast-moving objects that are crossing the Earth's orbit. But we're missing perhaps 100,000 of these things, of these county killers, city killers, country killers. So what we want to do is build a spacecraft called the Sentinel. And as we say, it's like looking for a charcoal briquette in the dark. These things are hard to find. They're tiny compared to the vastness of space. But infrared light, heat, bounces off of them. So what you'll do, you're a satellite, you're a surveying spacecraft, you'll get your back to the sun and look out from about the orbit of Venus and try to find all these asteroids. And then you find one, what do? Do you run in circles screaming? Ah! No. We've got to deflect it. Just a little. Just a tiny amount. Asteroid might be going 10 kilometers a second. We want to change its speed about 2 millimeters a second. So 10 kilometers, that's 10 times 1,000 meters. That's 10,000 meters. A millimeter, that's 1,000th of a meter. So that you take the 1 over the 1,000th, it's 1,000 times 10,000. That's 10 million. You want to change its speed at 10 millionth of its total. That's not very much. But if you're an asteroid that comes in at 10,000 tons, 100,000 tons, it does take quite a bit of force to change it a 10 millionth of its speed. Okay, how do we do that? Well, the easiest way is to get a rocket. Just a big rocket. Just go out there and just smack into it. Except it's in outer space, so it just goes like that. Okay, and that would change its speed a little. Now notice, everybody, what if it's not just a rock? What if it's a pile of rocks just loosely held together by primordial gravity? And so if you hit them, they'll just spread out and you'll have a shower of rocks. That would be bad. So, how about this? We'll get a big spacecraft that's massive. A massive spacecraft. And we'll go out there and just get near the asteroid. Just get near it. And then the mutual gravity of you, the asteroid, and me, the spacecraft, will tug tug the asteroid's speed just a little bit, just a tiny bit, or maybe get on the other side and tug it this way. That might work, but here's the problem. I need a huge amount of fuel for days and weeks and months and years. And what if it stops working? You can't go out there and fix it. Okay, how about this? The laser bees, a swarm of sunlight-powered lasers that are zapping the surface of the asteroid for days and weeks and months and years. Zap, 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 zap. So some asteroid, some rock is vaporized, and the ejecta, the stuff ejected, has momentum, just like rocket fuel, just like standing on a skateboard and playing catch with a bowling ball, the way you do. And so it would then cause the asteroid to change its speed. And so you send a swarm of these laser spacecraft so that if one of them stops working, you can use the other one. Or and you can have them come in from all different angles. And what if the asteroid is irregularly shaped like this? You could beam it when the thing is smooth, and then when there's a pit or an inefficient place to be beaming, you turn off, you wait for the asteroid to turn, then you turn it back. See, everybody, just because it's unlikely doesn't mean it's not a big deal. You know, if it only happens once every few thousand years, well, if it happens on my watch, it would, as the kids say, suck. Okay, so we don't want that to happen. We want to avoid that. Asteroids are serious business, but they're exciting. Except we're in space, so it's just... Got a burning question? Well, be sure to subscribe to ASAP Science. Follow us on Twitter and Facebook. That's what all the kids are doing. And if it's an asteroid, it may not be a burning question. It might be an impacting question, or even an ablating question.